Swarna Latha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about jointly Gaussian random variables in case of two random variables and n random variables. So, already in the previous lecture, we have seen the density function of a Gaussian random variable x. For example, if x is a Gaussian random variable, so then this random variable is said to be Gaussian what? When the density function of the random variable x is given by what? Fx of x is equals to 1 by square root of 2 pi sigma x square into e power minus x bar whole square by 2 sigma x square. So this is what? This is with respect to a single random variable x. So a random variable x is said to be what? Gaussian random variable if it has a following density function, where here x bar gives the mean of the random variable and sigma x square gives the variance of the random variable. Now we are applying the same concept for two random variables and n random variables. Now if you consider x and y are two random variables, then these two random variables x and y are said to be jointly Gaussian if they have the joint probability density function. So what is the joint probability density function of these two Gaussian random variables? Given by what? Fxy of x comma y is equals to what? 1 by 2 pi sigma x sigma y into square root of 1 minus rho square xy into e power minus 1 by 2 into 1 minus rho square into x minus x bar r as mu x whole square by sigma x square plus y minus mu y whole square by sigma y square plus 2 rho into x minus x bar into x minus mu x into y minus mu y by sigma x into sigma y. Here, what is sigma x? So, sigma x is called as what? Standard deviation of the random variable x. What is sigma y? Nothing but what? The standard deviation of the random variable y. And what is rho xy? Rho xy is called as what? Correlation coefficient of the random variable x and y. And what is mu x is called as what? The mean of the Gaussian random variable x. And what is mu y? Nothing but the mean of the Gaussian random variable y. Therefore, here what is sigma x indicates standard deviation of the two random variables x as well as random variable y. Rho xy represents the correlation coefficient and mu x represents the mean of the random variables. Mu y represents the mean of the random variable y, and sigma x square and sigma y square represents the variances. So already we know the definitions of standard deviations, means and variances. So what is sigma x square is called as what? So variance of the random variable x, and sigma y square is called as what? Variance of the random variable y. Therefore, two random variables x and y are said to be two random variables x and y with mean mu x and mu y and variance as sigma x square, sigma y square, and the standard deviation sigma x, sigma y, and the correlation coefficient of rho xy are said to be jointly Gaussian if they have this joint density function form. So fxy of x comma y equals, this is the formula for the joint density function of two Gaussian random variables. Now, so instead of representing that, I can represent the joint density function, the joint Gaussian density function by what? By y, right? By means what? Two, nothing but two random variables. How can I denote in shorthand? Nothing but what? N. N represents what? The normal distribution. Here, what is N represents? The normal. This is also called as what? The Gaussian. And what is mu x indicates mean of x. And what is mu y indicates mean of the random variable x. And what is sigma x square? The variance of the random variable x. So what is the short notation for this? Instead of representing all those things like this, you can represent simply by what? The normal distribution of the random variables x and y with the means mu x mu y and the variance as sigma x sigma y square and the correlation coefficient of rho xy. Here the variance of y also you are going to get. This is a shorthand notation for the jointly Gaussian density function for two random variables x and y. Now, if you consider the correlation coefficient rho equals to 0. So, when can you obtain the correlation coefficient equals to 0? If they are statistically independent or uncorrelated, then you can get this correlation coefficient equals to 0. And then in case of that, then what is the joint density function formula? This is joint density function for two Gaussian random variables x and y. So, in this formula, you have to substitute rho equals to 0. So, the correlation coefficient rho equals to 0, you have to substitute. Then what can you obtain here? 1 by 2 pi sigma x sigma y, square root of 1 minus 0 square. You get only 1. So, into what? E power minus 1 by 2. So, e power this is what? Minus. So, e power minus 1 by 2 into 1 minus 0 is nothing but what? 2 into x minus x bar square by sigma x square plus y minus y bar square by sigma y square. What about this rho value? You are considering that the correlation coefficient rho equals 0 for uncorrelated random variables as statistically independent random variables. Then how can you write down this function as what? 1 by 2 pi sigma x sigma y into e power minus of x minus x bar square by 2 sigma x square into, so you can write down this as what? 1 by 2 pi. So how can you write 2 pi sigma x sigma y is square root of 2 pi square into sigma x square into sigma y square into what? E power minus x minus mu x square by 2 sigma x square into e power minus y minus mu y square by 2 sigma y square. So, what is this? Then how can I write down this as what? 1 by square root of 2 pi into sigma x square into this term into 1 by square root of 2 pi into sigma y square into the second term. Then you can write down as what? So 1 by square root of 2 pi sigma x square into e power, what do you have here? Minus x y square by root 2 sigma x whole square into 1 by square root of 2 pi sigma y square into what? Minus of y minus y square by root 2 into sigma y square. Therefore, this is called as what? The density function of the Gaussian random variable x. And what do you call this as? The density function of the Gaussian random variable y. Therefore, fx of x into fi of y. Where what is fx of x? Nothing but the Gaussian density function of random variable x. And what is fi of y? Is called as what? The Gaussian density function of the random variable y. Therefore, if the correlation coefficient equals to 0, so then how can you get the correlation coefficient equals to 0? In case of x and y are statistically independent random variable. So then you can write down the joint Gaussian density function is equal to the what? Product of their marginal Gaussian density functions. Now we have seen for two random variables. Yes, we have seen for single random variable in the previous lecture. Now this is a joint Gaussian density function for two random variables. The same concept we are applying for what? N random variables. So if x1, x2 and so on xn are n Gaussian random variables, then their joint density function has been given by. For n random variables, how do you denote the joint density function? By what? F. How many random variables here? N random variables. So x1, x2 and so on xn. Therefore here also x1, x2 and so on xn of x1, x2 and so on xn is equals to what? 1 by 2 pi whole power n by 2. Here what is n indicates? N indicates the number of random variables. So for single random variable, you have to take n equals to 1. For two random variables, you have to take n equals to 2. For three random variables, you have to take n equals to 3 and so on. Therefore here what is n represents? N represents the number of random variables. So 1 by 2 pi whole power n by 2 into mod of cx power 1 by 2 into e power minus 1 by 2 into x minus mu x t, nothing but transpose here, cx inverse into x minus x bar. And here what we call this, all these are called as what? Matrices. So this already called this as what? This is a covariance matrix. So this is what? X minus X bar matrix. Okay. Therefore, here what is X minus X bar? Nothing but this is a matrix. X minus X bar is a matrix here. And here also X minus X bar transpose is also matrix. And Cx is also here what? Matrix. For that matrix, how to find out the determinant. It's nothing but here covariance matrix. Therefore, where what is X minus mu x? Nothing but this is number of rows. How many? N rows. And the number of columns only 1. So, this X minus X bar matrix of size N by 1. What is size? Nothing but N by 1. And what is the size of this matrix? X minus X bar transpose 1 cross N. 1 cross N. And what is the size of this matrix? N cross N. If you multiply these 3, then what is the total size you are going to get? 1 by 1. Therefore, X minus mu x is nothing but it is a N cross 1 matrix. It means it consists of N number of rows and 1 column. So, what is the first row represents x1 minus mu x1. So, what is x1? The particular element in the random variable x1. And what is mu x1? Represents the mean of the random variable x1. And what is x2 represents? The particular element in the random variable x2. And mu x2 represents the mean of the random variable x2. Therefore, mu x1, mu x2 and so on mu xn represents the means of the random variables x1, x2 and so on xn. So, we have defined this matrix. Similarly, how can you obtain the x minus mu x transpose matrix? So, x minus mu x transpose. So, transpose is nothing but no rows and column has to be exchanged. Therefore, what is the size? Nothing but the size of x minus mu x matrix is n cross 1. Then what is the transpose matrix? 1 cross n. It means what is the first element? x1 minus mu x1. This is the first row. And what is the second row? x2 minus mu x2. And so on. What is the nth row? xn minus mu xn. So this is what? 1 cross n. Only one row and n number of columns. Therefore, this is a transpose of this matrix. And here we have one more matrix in the formula with nothing but Cx. We have one more matrix. What we call it as Cx. So, what is the matrix Cx is called as what? Covariance matrix. So, what we call Cx as what? Covariance matrix. And what is the size of this matrix? Nothing but n cross n. The covariance matrix consists of n number of rows and n number of columns. And it is given by what? C11, C12 and so on C1n. Next C21, C22 and so on C2n. And the nth row represents Cn1, Cn2 and so on Cnn. So where what is C11? Nothing but what? Cx1, x1. And what is C1 to represent? Cx1, x2. What does it mean? C11 nothing but what? Covariance of between the two random variables, same random variable x1 x2, x1 only. And what is C12 represents? The covariance between the random variable x1 and x2. And what is C1n represents? The covariance between the random variable x1 and the random variable xn. So like that, what is Cij represents? So what is Cij? That represents the covariance between two random variables xi and xj. So what is the covariance of two random variables xi in formula? So expectation of x minus x bar into y minus y bar. So or else you can write down this as what? Expectation of x minus mu x into y minus mu y. So these are called as what? Means. Okay. Now what is Cij represents? Cij represents what? The covariance of the two random variables xi and xj. And this is represents the ith row and jth column. So what is C11 represents? First row, first column. C12 first row, second column. Similarly, what is Cij? Ith row and jth column. Nothing but xi random variable and xj random variable covariance between is called as what? Cij. Then what is the formula here? Cij equals to what? Expectation of xi minus mu xi into xj minus mu xj. Okay. Now, what is mu xi here? Mu xi is nothing but what? The mean of the random variable xi. And what is mu yj represents nothing but what? The mean of the random variable yj. So this is what? Mean of the random variable xi. So this is nothing but what? The mean of the random variable yj. Now, if I equals to j, then what will happen? Then what is Cij equals to? Expectation of xi minus mu xi. And j is also nothing but I only. Therefore, xi minus mu xi equals to what? Expectation of xi minus mu xi whole square. What do you call? This is nothing but the second moment about the mean. The moment about the mean is also called as second central moment mu2. This is called as what? Variance. So sigma xi square. Therefore, if I equals to j, then what is Cij equals to sigma xi square. If I is not equals to j, nothing but what? Cxi into xj only. Therefore, so this is a covariance matrix and the element in the covariance matrix. Now, this we are applying for two random variables. So, in this matrix, we are taking n equals to 2. Then what is matrix size? 2 cross 1. And what is transpose matrix size? 1 cross 2. And what is covariance matrix size? 2 cross 2. Therefore, we are considering two random variables x1 and x2. Then what is the matrix x minus mu? Previously, what is size? Equals to n cross 1. If n equals to 2, for two random variables, what is n value here? 2. Therefore, what do you get here? 2 cross 1. 2 rows. This is a first row and this is what? Second row. And only one column. What is the first element? x1 minus mu x1. And what is the second element? x2 minus mu x2. What is mu x1? Mean of the random variable x1. And what is mu x2? Mean of the random variable x2. And here this is small x1, x2. What is small x1? A particular element in the random variable x1. And what is small x2 represents a particular element in the random variable x2. And what is the covariance matrix size then? We are going to get. So what is Cx? In place of n, you are going to get 2. Then what can happen here? C11, C12, C21, C22. Now if I equals j, what I told you here? Cij. If I equals to j. So sigma xi square. So if here for C11, so 1 equals to 1, nothing but I equals 0. Therefore, how can I do this as what? Sigma x1 square. Similar here also I equals to 0. So this element also can write as what? Sigma x square. If I equals not equals to j, then what is the covariance matrix element? Cxi into xj. Therefore, here C12, what is I value? 1. What is j value here? 2. Therefore, this is nothing but what? Cx1, x2. And what is C21? Cx2, x1. Therefore, this is a covariance matrix for two random variables. Now, how can I write down the covariance in terms of correlation coefficient? Actually, what is the correlation coefficient formula? Nothing but what? The covariance between two random variables by their standard deviation. Nothing but sigma x1 to sigma. This is what? The correlation coefficient formula. So, in terms of the correlation coefficient standard deviation, then what is COV of x1 comma x2? Nothing but Cx1 x2 is equals to what? You can rewrite as what? Rho x1 x2 into sigma x1 into sigma x2. So, this is nothing but here rho x1 x2, the correlation coefficient of two random variables x1 x2. Therefore, I am rewriting like this. Therefore, what is the correlation coefficient formula? Rho x1 x2 equals to covariance of x1 comma x2. This is not y2, this is x2. So, covariance of x1 comma x2 by sigma x1 into sigma x5. RS can write like this also. C x1 x2 by sigma x1 into sigma x2. Then, here you have to find out the determinant, because in the denominator what you have here? Determinant of the matrix Cx. After finding the determinant, you have to take the square root. Therefore, find out the determinant of this covariance matrix. Then what can you obtain here? So, this is a covariance matrix. For this, calculate the determinant. Then you are going to get what? 1 minus rho x1 square, rho square x1 x2 into sigma x1 square into sigma x2 square. This is what? This is a determinant of the matrix. For the size of the matrix, I have taken 2 by 2 matrix. So this is a value. Now, so in the formula again, what you have to calculate? You have calculated the determinant now. What is n value here? 2. So 1 by 2 pi into 2 by 2. Into this, you have calculated the determinant of this covariance matrix. Now you have to calculate the inverse of the covariance matrix. So for 2 random variables, what is the covariance matrix? This is a covariance matrix. For this, you have to calculate what? Inverse. So calculate the inverse. How to calculate the inverse of a matrix? Adjoint of that matrix by determinant of that matrix. Then calculate the inverse of that matrix. Now what is the density function? Nothing but what? 1 by. So you are taking the which term you are taking? So this term you are taking. So you are considering first what you are doing? You are calculating x minus x bar transpose into cx inverse into x minus mu x. So all you have written for x minus mu x matrix. And what is x minus mu x transpose? So x minus mu x transpose is nothing but just changing rows into columns and columns into rows. So x1 minus mu x1. This is the first element. And second element nothing but x2 minus mu x2. So you know x minus mu. You know x minus mu transpose. And you know determinant of C. And you know the inverse of the matrix. Then substitute, calculate this value. Then what you are going to obtain? So 1 by 1 minus rho into x1 x2 into, so x1 minus mu x1 square by sigma x1 square minus 2 rho into x minus mu x1 into x2 minus mu x2 by sigma x1 sigma x2 plus this one. Then what is the formula for joint density function here? For n random variables, 1 by 2 pi power n by 2 into determinant of the covariance matrix x, and then you take the square root into e power minus 1 by 2 into x minus x bar transpose into cx inverse into x minus x bar. Therefore, substitute all these values. Then what you are going to obtain? You are going to obtain what? 1 by 2 pi square root of 1 minus rho square x1 x2 into sigma x1. This is nothing but what? 1 by 2 pi power n by 2 into mod of cx inverse determinant of the matrix cx. So cx of 1 by 2. So what is the determinant you got here? 1 by this value you are going to get. So if you substitute, then you are going to get the joint density function for 2 Gaussian random variables. So previously you have written the formula for the joint Gaussian density function for 2 random variables. What is the formula? 1 by 2 pi sigma x sigma y square root of 1 minus rho square into e power minus of 1 minus 2 into 1 minus rho square by x minus mu x square by sigma x square plus y minus y mu y square by sigma y square minus 2 rho into x minus mu x into y minus u by sigma x into sigma y. So which you have obtained here. So previously we have seen the Gaussian density function for 2 random variables. So this, if you compare that one, you are getting the same expression. Similarly, we can write down the joint Gaussian density function for 3 random variables, for 4 random variables, for 5 random variables, and so on up to n random variables. And coming to the properties of Gaussian random variables, the Gaussian random variables are completely defined their mean and covariance matrix. It means if you see the joint Gaussian density function of n random variables, how they are defined? What is mu x and mu y represents? The means of the random variables. And what is cx indicates? The covariance matrix. That's why what the first property states that? The first property states that the Gaussian random variables are completely defined thereby mean and covariance matrix. And with the second property, the sum of many uniformly small and negligible random effects tends to be Gaussian. So for example, we are taking n Gaussian n random variables and you are adding this n random variables. If n tends to infinity, then the density function of these random variables approaches what? The Gaussian density function. And what the third property states that if the Gaussian random variables are uncorrelated, then you can say that they are statistically independent. And the fourth property states that what? The weighted sum of jointly Gaussian random variables are also again what? Jointly Gaussian random variables. What does it mean? For example, if x1, x2 and so on xn are n Gaussian random variables. So weighted sum is nothing but I am taking what are the weighted random variables here? AX1, let us say A1x1, A2x2 and so on, ANxn. Weighted sum is nothing but I have take A1x1 plus A2x2 plus and so on, ANxn. Okay, so where what are the x1, x2 and so on, xn are what? N Gaussian random variables. So if x1, x2 and so on, xn are n Gaussian random variables, then the weighted sum of these n Gaussian random variables is also approaches what? Again, the Gaussian density function only. And the fifth property states that the joint conditional density function of jointly Gaussian random variables given the values of some other condition, then again is also condition. What does it mean? For example, x1, x2 and so on, xn what? N jointly Gaussian random variables. Now what you are doing? We are calculating the conditional density function. So if x1, x2 and so on, let us say xn. Okay. Then what is the condition you are taken here? x1, x2 and so on, xn by what is the condition you are taking here? Some xn plus 1, xn plus 2 and so on. Then this the joint conditional density function, the conditional density function will also again approaches what? The Gaussian density function only. What I am saying here? x1, x2 and so on, xn are jointly Gaussian. What is the density function here? fx1, x2 of xn of x1 to xn. Similarly, if you take the conditional density function means for that you have to give some condition. Then the conditional density function is also again what? The Gaussian density function itself. Therefore, in today's lecture, we have seen about the Gaussian random variable for two random variables as well as for n random variables. After that, we have discussed about the properties of jointly Gaussian random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.